Hi friends, welcome back on our YouTube channel. In today's lecture of classical mechanics, we are going to discuss about Hamilton's equation of motion in Poisson bracket formalism. In last lecture, we have discussed about Poisson bracket. Now, Hamilton's equation of motion in Poisson bracket formulation. So, let's start with this lecture. Hamilton's equation of motion in Poisson bracket formalism, or this is also known as Poisson's theorem. If we have a function u and u is a function of q1, q2, qi, p1, p2, pi and t, it means u is a function of qi, pi and t, or the coordinate, momentum and time. So, if we differentiate u with respect to time totally, then du by dt is equal to sigma I del u by del qi into qi dot plus del u by del pi into pi dot plus del u by del t. From Hamilton's equation of motion, we have already discussed about Hamilton's equation of motion, and the link of that lecture is given in description box. So you can read that lecture from there. From Hamilton's equation of motion, qi dot is equal to del h upon del pi and pi dot equal to minus del h upon del qi, and here h is Hamiltonian. So we replace this qi dot by del h upon del pi and pi dot by minus del h upon del qi. So du by dt is equal to sigma I del u by del qi into del h upon del pi minus del u by del pi into del h upon del qi plus del u by del t. Now, from the definition of Poisson bracket, the Poisson bracket of u v with respect to p q is given by this one, and here in place of u we have u and in place of v we have h. So this is actually the Poisson bracket of u and h with respect to pq. So du by dt is equal to Poisson bracket of u and h plus del u by del t. Now this is our du by dt. If u is a constant of motion, so u does not depend on time, it means du by dt equal to 0, because u is constant of motion, so du by dt is 0. Now we put a 0 here, so the Poisson bracket of u and h plus del u by del t is equal to 0. If u does not explicitly depend on time, so if u does not explicitly depend on time, then del u by del t equals to 0. So del u by del t equals to 0. So we put here 0. It means the Poisson bracket of u and h equals to 0. And this is Poisson's theorem, or Hamilton's equation of motion in Poisson bracket formalism. Here we end our session. Today we have discussed about Poisson theorem. Goodbye.